we'll try to find the inverse of a 3 by 3 matrix using an elementary operation. So let us take an example matrix here, where the matrix A is equal to 1, 4, 3, 2, 4, 7, and 1, 5, 2. So I have taken a matrix here, assume the matrix. So let us find the inverse of this matrix and then let us verify whether A inverse is equal to I. By doing so, we can confirm that the matrix that we have found in terms of the A inverse is correct. So the first step, as we have discussed for a 2 by 2 matrix, the same one we'll do. We'll write I separately here, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. And the first step here is to write A equal to AI. So A equal to AI. So we'll write this. So this is the format. So A left hand side A is 1, 4, 3, 2, 4, 7, 1, 5, 2, which is equal to A into the identity matrix for a 3 by 3 is 1, 0, 0, 0, 1, 0, and 0, 0, 1. So our first intention is to find the value of first A11 as 1, or convert the value of A11 as 1, which is already 1 here. So we'll start with this element, which is already 1. So the next element is we have to make this and this 0 here. So to do that, my row 2 is 2 here. So to make this as 0, my row 2, my new row 2 will be my previous row 2, which is 2 minus 2 times of R1. That will make it 0. So since my row 3 and row 1 is not going to have any alteration in this step, so I'll write these two rows first. So 1, 4. So my row 2 is being altered. So my row 2 will be row 2 gives row 2 minus 2 R1. This is my operation. So 2 minus 1 into 2, that will be 2, that is 0. So that will be 0. This is why we have created this row. So this will be obviously 0. Now my second element, that corresponding element I have to take. So this is 4. So 4 minus 2 into, I have written the operation, into 4, that will be 8. So 4 minus 8, that is equal to minus 4. So this is minus 4. The same way, the third element is, this is 7. So 7 minus 2 into the corresponding element on the first row is 3. So 7 minus 6, that will be 1. So the same operation has to be done on the right hand side. So 0 minus 2 into 1, that will be minus 2. This is minus 2 from these two operations. Then this is 1 minus 2 into 0, it will be 0. So that is 1 here. So 0 and 0, this is 0. So 0 minus 2 into 0 is going to be 0. So we have completed the first operation. The same way, let us go ahead and convert the third row as 0. So to do that, my row 3 will be row 3 minus row 1. That's enough, as this is 1 and this is 1. So to make this 0, all I have to do is just subtract. So my current new matrix will be in terms of row 3 is getting altered. My row 1 and row 3 will be the same from this matrix. So I'll write the row 1 and row 2 first. 0 minus 4, 1, 1, 0, 0, minus 2, 1, 0. Now the operation 1 minus 1, 0, 5 minus 4, 1, 2 minus 3 is minus 1. So since it is easy, I didn't write it in this workout area. So this is 3 minus 1, 2 minus 3, that is minus 1. Now 0 minus 1 is minus 1, 0 minus 0 is 0, 1 minus 0 is 1. So we have completed the first column, right? That is, the first column of the required matrix is being completed. So the next step is to convert the identity element as 1 in the second column. If you see here, this is 4, and if we have converted, right, we have converted that into minus 4 here, right? So when we did the operation, it has become minus 4. So this could be achieved only by dividing it by minus 4. The other operation, if it is employed, it will make it complicated. So we'll make row 2 as row 2 divided by minus 4. So again, my other rows are not altered. 0 by anything is 0, minus 4 by minus 4 is 1, 1 by minus 4 is minus 1 by 4, this is minus 2 divided by 4, minus 4, that will be 1 by 2, this is minus 1 by 4 and this is 0. So we have converted the identity element as 1. Now the other two steps will be making the other two elements of this column as 0. So we have to convert this as 0 and this as 0. The order could be changed here. The order is not an issue when we do the other two elements. That is the non-identity elements in any of the column. So let me convert this as 0 first. So my row 1 will be now row 1 minus 4 row 2. As you can see, this is 4. So 4 minus 4 into 1, that will be minus 4. That will make it 0. So since I am altering my row 1, so 0, now 1 minus 0 into anything will be the same, that is 1. That's why we didn't convert this with the help of the other rows, which will make this value will be non-zero, which will not of any help. Now this will be 0 as we have created this operation purposely to make it 0. Now my operation here is row 1 is row 1 minus 4 row 2. So when I do the operation, this will be 3 minus 4 into minus 1 by 4. That will be 3 plus 1, minus and the minus is plus. 4 by 4 will cancel, so that will be equal to 4. So this is 4. Now my right hand side will have, this is 1. So row 1 is 1 minus 4. That is 1 minus 4 into 1 by 2. That will be equal to 1 minus 2. That will be minus 1. The same way, this will be 0. Minus 4 into minus 1 by 4 will be plus 1. So this is 1. Since both are 0, this will be 0. So we have completed the row 2, column 2. Now we have to convert this as 0. Right on the left hand side, we have one more column 2 element which has to be made 0. So we'll write the operation as to make this 0. All we have to do is we have to subtract. So row 3 gives row 3 minus row 2. That will give me, so 1 minus 1 by 2 minus 1 by 4, 0. My third row is getting altered. So let us do the operation. So to do the operation, we will stick on to the operation that we have written. So this 0 minus 0, 0, 1 minus 1, 0, then minus 1 minus of minus 1 by 4. That will be minus 1 plus 1 by 4. That is minus 4 plus 1 the whole divided by 4, which is minus 3 by 4. So this is minus 3 by 4. Then this is minus 1 minus 1 by 2. So that will be minus 3 by 2. This is 0 plus 1 by 4. This is 1 minus 0 into something is 0. So we have completed the second column. So the third column is left out, which has to be completed to find the A inverse. Now this is minus 3 by 4. I have to make it as 1. So my row 3 will be equal to row 3 into minus 4 by 3. I'm multiplying that with the inverse of the value that it has. So it will make it 0 into anything 0, 0. So minus 4 by 3 into 3, minus 3 by 4 will be plus 1, which is equal to my right hand side. It will be, I'm writing the unaltered rows, 1, 0, 4. 3 by 2 minus 3 by 2 into minus 4 by 3, minus into minus is plus, 4 by 2 is 2. So this is 2. Then 1 by 4 into minus 4 by 3 is minus 1 by 3. 1 into minus 4 by 3 is minus 4 by 3. So this is the right hand side. Now using this element, that is the identity element, we have to make row 1 and row 2 elements along the column 3 as 0. So row 1 gives row 1 minus 4 row 3. So that will be 4 minus of 4. So since only the row 1 is getting, so this is 1 minus anything into 0 will be 0. So that is 1. So 0 and 0. So whatever operation you do, this will be 0. 4 minus 4 will be 0. The right hand side will be minus 1 minus 4 into 2. That will be minus 1 minus 8, which is minus 9. So this is minus 9. The same way 1 minus 4 into minus 1 by 3. That will be 1 plus 4 by 3. 3 plus 4, 7 by 3. This is 7 by 3. This is 0. So that will be 0 minus of minus plus 4 into 4, 16. This is 16 by 3. So the last element has to be completed. With that, we will get the A inverse. So the last element is this one has to be 0. So to make this 0, all I have to do is my row 2 is equal to row 2 plus, since this is already minus, I have to add 1 by 4 with this. So 1 by 4 of 1, that is my row 3. So this will not alter my row 1 and row 2, row 3. So we'll write row 1 and row 3 first. This is 0, 1. We have purposely created this to make this 0. So this will be 0. So only the right hand side I have to do the operation. So the operation is row 2, that is 1 by 2 plus 1 by 4 of the row 2 element, row 3 element. So this is 1 by 2 plus 1 by 2, that is equal to 1. So this is 1. Then minus 1 by 4 plus 1 by 4 of minus 1 by 3. That will be minus 1 by 4 minus 1 by 12. That is equal to minus 3 minus 1 by 12. That is minus 4 by 12. That is minus 1 by 3. Finally, this is 0. So 0 plus 1 by 4 into minus 4 by 3. That will be minus 1 by 3. This is minus 1 by 3. So we have arrived at the A inverse. As my left hand side is I equal to AB matrix, B matrix has to be A inverse. Now all we have to do is we have to check whether this A inverse is correct. Now to check whether we have arrived at the correct matrix, let us write the A inverse and A and multiply to check whether we are getting the matrix I, that is the identity matrix. So my A inverse is to multiply. We already know that matrix or multiplication should be rows into column and the corresponding element should be multiplied. So to do that, first row into first column will be my first element. So that is my matrix is equal to minus 9 into 1, that will be minus 9, plus 7 into 2, that is plus 14 by 3, that will be 7 into 2, 14 by 3, plus 16 by 3. So if I multiply this into 1, that is 60. So now to check whether this is correct, we can start for every element we could check so that whether it is correct or not. So to do that, my first element is minus 9 plus 16 plus 14. That will be 30 by 3. That 10 minus 9 plus 10, which is equal to 1. Yeah, that is correct, right? My first element should be 1. Now the second row into second column, first row into second column. Now the first row into second column, minus 9 into 4 minus 36 plus 7 by 3 into 4 plus 28 by 3 plus 16 by 3 into 5, that is plus 80 by 3. So this is the element. Now again we can check what is the value of this. So that is minus 36 plus 80 plus 28, 108 by 3. So 108 by 3 is again 36. So minus 36 plus 36, that is equal to 0. So this is again correct, the right value that we have got, because it has to be 100 And the third element will be first row into third column, that is minus 27, 9 into 3. Then it is 7 by 3 into 7, that will be plus 49 by 3. Then 16 by 3 into 2, that is 32 by 3. So if you simplify this too, it has to be 27. So 40, 70, 81 by 3. 81 by 3 is 27. So minus 27 plus 27, it will be 0. So then the second row into first column will be my A21 here. This is my A21, that is second row into first column. So to do that, I'll multiply my second row into first column, that is 1 into 1, that is 1, minus 2 by 3, minus 1 by 3. So if we simplify this, minus 2 minus 1 is minus 3 by 3, that is minus 1. 1 minus 1 will be 0. So this is correct. Now for second row into third column, that is 1 into 4 is 4, minus 4 by 3, then minus 5 by 3. So this will be minus 9 by 3, which is minus 3. 4 minus 3 is 1. So we'll get the right value. Then the third element in the second row is 1 into 3 is 3, minus 7 by 3, minus 2 by 3, which is again minus 9 by 3 is minus 3, minus 3 minus 3 is 0. Finally, the last row, that is third row into first column, is 2 into 1, 2, minus 2 by 3, minus 4 by 3, that will be minus 6 by 3 is minus 2, so this is getting 0. Then 2 into 4 is 8, minus 4 by 3, minus 20 by 3, that will be minus 24 by 3, minus 24 by 3 is minus 8, so 8 minus 8, it is getting a 0. Then the final element will be final row, third row into final column, that is the third column, 2 into 3, 6, minus 7 by 3, minus 8 by 3, minus 4 by 3 into 2. So if we add this minus 15 by 3, that will be minus 5. 6 minus 5 is 1. So the final answer that we are getting here is the identity matrix, that is 1 0 0 0 1 0 0 0 1. So the answer is correct. Therefore, the A inverse that we have found is the correct value, that is minus 9, 7 by 3, 16 by 3, 1, minus 1 by 3, minus 1 by 3, 2, minus 1 by 3, and minus 4 by 3. So this is the way you could employ elementary operation to find the A inverse. There is one more method that you could use, determinant method, to find the A inverse, which will be a little bit easier than this. But care should be taken when you do the operations, so that you don't go wrong while taking the minus signs or taking the corresponding elements of the rows. So each and every step, do it very slow so that you'll arrive at the correct answer. Thank you. Happy learning.